Hey Dr. Rose, this is our 3D printed brushed DC motor that we made for your mechatronics class. So we just wanted to walk you through a couple of the design features that we thought were kind of cool and sort of made our project a little unique. So our entire design was 3D printed except for the bearings and the metal and things like that. So we used a modular design. So if you can look at the bottom here, you can see how we have some interference fits. So we did a lot of playing with my 3D printer and the tolerances on it to establish tight fits for all these parts such that we didn't have to use any fasteners or anything like that. So that allowed us to switch out each of these parts individually, like you could just pop these out. So if one of the prints failed or something like that, we could easily switch them in and out or make modifications, make improvements.
That was specifically helpful for this piece right here, this piece that holds our brushes. We redid it about 5 times, I think. So it was really nice to be able to go back, tinker with it in SolidWorks, print it up again, and be able to see if it works right away without having to reprint the whole thing. So it was very convenient.
Yeah, and then continuing to look at more parts of it that we thought were cool. We have a non-ferrous core that we 3D printed on the 3D printer as well. So that allowed us to achieve a design that we were wanting in SolidWorks and then print that. So it was the exact shape that we wanted with the number of arms that we wanted, and we didn't have to fiddle around with manufacturing it in some way. So that allowed us that flexibility for winding. So we have 40 turns per arm. That was a calculation that we did just looking at, and that was an educated guess sort of that gave us the torque and speed figures that we were hoping that would achieve successful design for the project. And then also looking at our commutator, that's another innovative design that we thought we had. We used a monster can that we cut into small slivers that these wires ride up against. So that was how we gained contact from the brushes, and we connected that to our wires that generated the magnetic field. And then we also used bearings in our design as well. So these are some bearings that Steven found on Amazon.
The bearings just reduce the friction and make it spin a little bit easier and have just make it a little bit faster.
Yeah, and so overall that gave us a pretty smooth design that minimized friction as much as we could without buying really high-end bearings or anything like that. But we achieved slightly higher or lower friction as a result of that. So we think it came together pretty well. At the onset, we wanted something that looked kind of cool and would be sort of something that we might want to put on our shelf when we're done. So I think we achieved that, and we're pretty happy with the product.